Hi there, I'm Matthew Wilson, and I'm the Pre-Employment Transition Specialist at Jefferson Community and Technical College. And I'm really excited that you have joined us today to witness space history and to learn how you can get into a career in the aerospace industry right here in Kentuckiana. As you probably already know, there was an SUV-sized vehicle that took off from Cape Canaveral in Florida on July the 30th, 2020. Now, after 6.5 months, it is in Mars orbit, and it's about to start what's known as its EDL, which is entry, descent, and landing. A 7th grader from Northern Virginia, whose name is Alex Mather, actually gave this vehicle its name. He called it Perseverance or Perseverance. He won an essay to get that honor, and NASA chose it because it knew that literally thousands of its workers, engineers, techs, office support, logistics people, heck, chefs, baristas, and all sorts of other unnamed people, it took all those people to get the Perseverance rover off the ground on July 30th, especially in the middle of a pandemic. Now, Perseverance mission is basically got 4 or 5 parts. It's going to collect rock samples that will leave behind on the Martian surface to be picked up later. It's going to launch its the first aircraft that ever went into the air on another planet. It's a little helicopter called Ingenuity. Perseverance will also test technology that is essential to future human settlement of Mars, including a device that a lot of people probably learned about in a high school chemistry class, which will turn the Martian atmosphere into usable rocket fuel and also oxygen. And finally, and probably most exciting for many of us, Perseverance mission is to search for ancient microbial life that may have once existed on the red planet. So if all goes well, I have a clip here coming up. It's a 1-minute long animation that shows what this landing, this EDL, will look like. Yeah, that's much more exciting to me than watching all of the Star Wars movies back to back, or at least it takes less time. So that's what it's supposed to look like. We don't know. We won't know because we will be going through this, I think it's called 7 minutes of terror, where the actual craft will be completely on its own, autonomously doing all these maneuvers that you just saw. Certainly anything that you reference or see here in this event today, you can go to nasa.com and learn more about. But the purpose today is also twofold. The second thing we want to be sure that you know is we want to let our participants, whoever you are, wherever you're coming in from, we want you to know that you can work in careers in the aerospace industry right here in Kentuckiana. Like I said, this industry is growing very quickly. And if you keep track of any of the work being done by NASA, by SpaceX, by Blue Origin, you know that it's only going to grow. And you may also know or not know that Kentucky's largest export is actually aerospace. So right here in our backyard, you may have the opportunity to go into one of these careers. So our first speakers today will be from this industry. And then later on today, we'll have a second session that we will help you get to if you want, which will bring in some academic voices. But our first folks today belong to this industry. and they're going to help you by teaching you about their companies, pave the way for you to become part of, as Elon Musk has said, a multi-planetary species. So what I want to turn to now is a brief introduction of Mr. Rich Bowling, who is from a company called TechShot, which is to our north in the great state of Indiana. He's going to tell you about his company. He serves as vice president of TechShot Incorporated. It is a Metro Louisville-based space technology and services company that developed its own large catalog of research and manufacturing equipment. It's been at work since 1988. Its payloads have flown on parabolic flight aircraft, suborbital rockets, space shuttles, Northrop Grumman Cygnus cargo vehicles, the SpaceX Dragon cargo vehicles, and the ISS, the International Space Station. So they do a lot, and they do a lot from a little venue in a place called, Greensburg. There's so many greens in Indiana.
Greenville, yeah.
Greenville, Indiana. So I'm going to turn this over to Mr. Bowling. Oh, you know what? I skipped you, Telly. I guess Telly needs to put in a piece first.
Hey, Matthew, put me where you need me. Matthew, put me where you need me. I'm so excited about today. I know you're excited as well. We got so much energy with the campus. So you put me where you need me and I can talk. I'm so excited to be here. Let me know.
All right. Maybe we could slip you in, since I got a big introduction done, between Rich and Miss Morton. That's okay with you.
That would be absolutely fantastic. I'm
apologize to Miss Morton, who's our next speaker. Go for it, Rich.
All right. So thanks so much. I'm just really excited to be able to share in this event with you today. You're right. Folks don't always think about this area as being one where aerospace plays a big role, but it really does. And TechShot has been here for the entire time of our 30-year existence, employing folks. Probably half our employees are from Kentucky, half from Indiana. It's truly one metro, and we think a rising tide raises all ships. And we hire a lot of folks from U of L, a lot of grads from U of L as well, and from other regional schools. So let me tell you a little bit about TechShot and how maybe you might play a role here someday. TechShot actually was started by one of our co-founders' 8th grade science project. So as a student, you wouldn't think that perhaps one day you could create a space company that could employ a lot of people and put things in space. But I encourage you to dream big and take those science projects in middle school and in high school seriously. So I'll show you a little video and I'll narrate it a little bit as we go along. So we can go on and take a look at that. So one of the first folks you're going to see here is it's a bit of an old video clip showing one of our co-founders actually doing some work on that original project. So here he is down at NASA, and he's now a little bit older. He's no longer in middle school. This is when the project finally got aboard the shuttle. And that's where we started, was building these research payloads for the space shuttle. Now you can see we work aboard the International Space Station. I love seeing that TechShot logo there on all these payloads as they're being installed. So everything you're seeing here is something that we designed, built, and that we own and operate on board the International Space Station. This is our 3D bioprinter that we have on board the space station, with our aim of making human organs and tissues at some point. It's a long process, but we're on that road now. So all these are just devices that we provide to our customers. So most of the research in these devices is not TechShot research. It's a NASA researcher. It's a researcher from a university. It's a researcher from a commercial industry. And they lease our equipment from us. And we get them aboard the station. We have access to space. We have agreements with NASA that let us sort of function as a commercial front door to companies that want to get aboard the station to do their research. Even things like plants, where we partnered with Tupperware to develop new plant growth systems for the International Space Station. But and this is after one of our most recent experiments. We're pretty excited. This is where we control our equipment. We have a little mini mission control at TechShot here. Greenville, Indiana is in Floyd County, so it's where New Albany is. Greenville is within the same county, just about 5 minutes up up Interstate 64 a little further west. So yeah, we had a little mini mission control where we talk directly to the astronauts. We see in real time what they are doing with our devices on board the space station, and we work together in that way. There are a few places around the country that have that sort of capability and that do that, and TechShot's one of them. We also have an office and a laboratory at the Kennedy Space Center where we have a staff there that works primarily on plant work. So we go on to the next slide. You can see some of these other devices as they look like on board the station. You were introduced to them as they were being installed, mostly in that video clip. But this is just an array of some of the things that come and go from station. We always have several things on board, but many others come and go from the space station all the time. TechShot has equipment or research samples heading to the International Space Station on every single cargo spaceship that goes to the station, whether that's a SpaceX Cargo Dragon or whether that's a Northrop Grumman a Cygnus cargo vehicle. We're very busy and keep things coming and going all the time. Now, these things are chiefly really looking at ways to live in space for long periods of time. Our customers are really trying to help NASA, in one sense, thrive on a very long journey to Mars, because it takes 8 to 9 months to get to Mars, as we know, and then to live off the Earth, let's say on the surface of Mars for a long period of time. You might need to be able to have some new technology related to crop science. Can you feed yourself? Can you just take some seeds with you and grow new crops, or even manufacture a steak? Let's say if you're hungry for some beef, and you might do that with we'll take the next slide. And so we have this 3D bioprinter for the space station. We're chiefly looking at, as I mentioned, human tissue, manufacturing human tissue, but they could also just as easily manufacture a steak if you wanted some high-end Wagyu beef or a hamburger or whatever you might be missing on this long journey to Mars and on the surface of Mars and back. So we'll go to the next one. So if you've got your steak, here's your salad. TechShot didn't build the advanced plant habitat on board the space station, but we do manage it. And we're really happy that we just helped grow 2 major crops of radishes on board the station, and it went great. The astronauts tried them and said that they taste like delicious radishes. And even just orbiting aboard the space station, where crews can stay on about 6 months at a time, they talk about the value of tending a crop, and just from a psychological perspective, the value of that experience, seeing things, leafy greens grow, and then just tasting fresh food is really important to even astronauts aboard the space station, let alone millions of miles away on the surface of Mars. So we're very happy to play a role in NASA developing these capabilities to grow crops on the station, on the moon, on Mars. Next slide, please. Another important one that we're working on here is we call Fab Lab. So this is the prototype of a large 3D printer that we will again own and operate. And right now we're printing titanium tools, parts, replacement parts, something that if you think you're millions of miles away, you need to be pretty self-sufficient. And having a 3D metal printer on hand, and one that can actually do whole electronic assemblies as well, that's going to be essential for enabling long-term exploration of Mars. You know, the communications delay between Earth and Mars is about 20 minutes. So we won't find out about the landing of this rover, frankly, until 20 minutes after it's actually happened. And so communications from Mars to Earth is a little problematic. You can't just talk to one another easily. So having something that can help you be self-sufficient, such as this metal printer, will be really important. We hope to launch the first prototype to the space station within the next 3 years or so. So the last clip I wanted to show you, if you'll go on to the next slide, is some testing on board one of these parabolic flight aircraft. That's me kind of fumbling around. Some of the other friends there at TechShot are strapped down. That's why you don't see them float. And folks, let me tell you, it's harder than it looks. Floating in 0G is quite hard. And the very first time we got into 0G, I just bounced around the aircraft, and people had to grab me like a runaway Macy's Thanksgiving Day parade float and pull me back down to earth. What you're seeing now is probably the 25th time we got into zero G. You're only floating for about 30 seconds at a time. And sometimes you've heard this nicknamed as the vomit comet. And I'm very pleased to say my lunch stayed in place during this flight. But it was an amazing opportunity, and this is how sometimes we do test our technologies, see how they'll work in space. The bioprinter, we did the same thing, and it worked well. And it's just part of the process. So if this sounds interesting to you and you think a career in this industry is appealing, if you have any questions, you can reach out to me there at my email address. I think this is a terrific time to be involved in pursuing a career in space. These are the golden years, I will say. I think this is the golden age of space flight. Often we think about the 1960s, the 1970s with the Apollo program, or maybe the 1980s and 90s with the Space Shuttle program. But now you've got so many more ways to reach space. You've heard talk of Blue Origin and SpaceX. And NASA, of course, is building its own giant rocket to go back to the moon and onto Mars, a space launch system. But so many companies and so many organizations developing ways to get to space and then thrive in space means more jobs for all of us who want to be involved. And if you want to be an engineer or a scientist, I think obviously those are the traditional front doors to the industry. But if you're an artist, if you're an accountant, if you like math, if you like drawing, there's a role for everyone in this industry. You've heard of STEM, of course, space, science, technology, engineering, and math. But STEAM, science, technology, engineering, arts, and math are becoming increasingly important too. So congratulations on those of us that are participating in this call today. I think we all have a perspective on what this industry can be, what the implications are on the region. And for any students that are watching, I encourage you to reach out to any of us and let's talk about what kind of path forward we might recommend to get you in space one day, maybe. So thanks a lot.
Thank you so much, Mr. Bowling. I was very excited when you said yes, and you made the promise to me that you loved talking to young people about this, and so I think Telly and I are going to keep you in on our quick dial, as they used to say, on our speed dial. So we'll be back in connection with you. Thank you very much, and your company sounds amazing. You probably don't need a place for an old used up teacher, but if you do, I'm available. I can drive up there.
You're on my short list.
Thank you very much. Appreciate it. I would like to switch now to Ms. Morton. Those of you who have heard Mr. Bowling talk, you realize that he's from just over the river. Well, Ms. Morton, among other things, and the information she gave me about herself, is she is a local person. She is from Louisville. She was born and raised in Louisville, 6 brothers and a sister. She attended DuPont Manual High School. So if some of you all are coming in from DuPont Manual, there she is, one of your own. She also went to Murray State, which is interesting because in our next session, we're going to have someone from there. Dr. Grupa is going to speak to us from Murray State. And she had a major in biology and minor in chemistry. Good for you. There's a lot of other things that she's got. She's quite an amazing lady by the look of these things. I'll just mention a couple. She was Harshaw Chemical tested pigments. She did environmental consulting. She is presently at American Synthetic Rubber, which started in a main lab in 1986, right here. She works in the ASRC, that's the name of their company shortened, environmental lab. And this is the reason we got her here. She started working in the liquid polymer lab in 1992. And she has, she's going to talk more about how that plays into the NASA SLS program. And finally, I could not pass this one up because this was sounded so cool. She received the Silver Snoopy Award in 2002. I hadn't heard of it, but it sounds cool. She says it was a special honor awarded to NASA employees and contractors for outstanding achievements related to human flight safety and mission success. I bet there's a big old story behind that, which we won't have time for today. So you're on my speed dial too. I want to learn more. The award certificate states that it's an appreciation for professionalism, dedication, and outstanding support that greatly enhance space flight safety and mission success. And the last thing for any young ladies who are out there, her favorite movie is Hidden Figures. And whether you're a young lady or a young man or an old lady for that matter, that's a movie you need to see. That's a fantastic story. So, Miss Morton.
Hello, good afternoon. My name is Linda Morton, and thank you for Matt for the tremendous introduction. Well, Mr. Bowling from Tech Shot talked about all the technology upon the different space vehicles, but to have that, you have to get up in the atmosphere first.
That's right.
So our product is called P-band, polybutadiene acrylonitrile rubber, and that's what my slide is going to show you what we've done and show you some of the lab instruments, show you some of the testing that we do. So we're going to start the presentation now. The name of the space program vehicle is Artemis. Apollo was a space shuttle. Artemis is his twin sister, Apollo's twin sister. So humanity is going to return to the moon. And the Artemis program intends to land astronauts to the moon's south pole by 2024, and that's 4 years ahead of the plan. But what is especially interesting to me are that the mission will also include the first woman to walk to the surface of the moon. Next slide, please. Now, before they send someone off into space, they want to test to make sure all the raw materials work together. So they have a booster test every year. So in September, they had a booster test, September the 2nd, 2020. And I hope this link works so we can see the static testing. Next slide. If you could see if you can launch that slide. Well, if not, this is just, if it won't launch, you can just see this is a picture of the static testing. It's done in Promontory, Utah, and it's way out in the middle of nowhere. And you can see here that the sights and sounds of, if you ever get to see it, it's magnanimous. Oh, here you. One picture is worth 1,000 words if we can see it. That's not it. That doesn't represent our plan.
Houston, we had a problem, but it's over.
There you go. This is very interesting. Just look at this. This is out, and there are farms and homes all around there on the other side of the mountain. You're going to see they have a special contract with Northrop Grumman, that because their pools get dirty, their houses get covered with dirt. You're going to see why. But to see this, I haven't seen it live. I saw it where it was happening, and it is awesome. Our product, our P-band product is in here. There you go. That's just one booster. But when it takes off, it's when the space shuttle or the Artemis takes off, there's two boosters on either side of it. The first 2 minutes of the space shuttle launch, our product is gone. So I'm just going to keep quiet. I don't know if you can hear the what's being said along with it. But before I retire, I want to go and see this live. And you can imagine that on a stand with two of those space boosters on either side. And the most interesting part is at the end of it, when they want to quench the flame, a little robotic arm comes out and sprays a distinguishing liquid on it. It took a lot of work here at American Synthetic Rubber to provide the polymer for that static testing. And I have a little bit of information about how much work and effort and testing went into that. You can probably skip to the end. And that's after it's been extinguished. And you see the little arm going there. We got to make sure we get all this out. So you can imagine if you had a farm or a house around there, this may not be the best selling point for someone looking for a new home. Okay, this test was dubbed the Flight Support Booster 1. It ignited at 3:05 and it burned for approximately 2 minutes and 2 seconds. And the test stand is 154 feet long, and it generates over 3.6 million pounds of thrust during the test. And when combined with a second booster, it will be responsible for nearly 75% of the thrust of NASA's Space Launch System rocket. Next slide, please. Okay, you can go to the next one. NASA is assembling the Space Launch System rocket boosters to power the Artemis moon mission. NASA completed a full-scale booster test on 2nd of September. NASA has a contract with Northrop Grumman to build boosters for future rocket flights. The SLS boosters are the largest, most powerful boosters ever built for flight. The rocket booster provides 75% of the thrust needed to launch the future and deep space missions. Northrop Grumman is the lead contractor for SLS boosters. And they've asked them to use, these were used on all the space shuttles, but they wanted to use proved technology because of 135 missions. I hate to say only 2, because any loss of life is bad, but only 2 space shuttles ended up with tragic demise of several people. So that's to me, 2 out of 135 is a good percentage. The next slide, please. ASRC has provided P-band for many of the vehicles. We started in 1957. We have provided P-band for the Minuteman, Polaris, the Space Shuttle, as I said, Titan II and Titan IV launch motors, and for the refurbished Minuteman, and then, of course, the crew launch vehicle, which will go up first, and then the heavy launch vehicle, which will carry crew and equipment. Next. This is some more information about the solid rocket boosters. The height of it is 17 stories high, which is taller than the Statue of Liberty from base to torch. It's a 1.6 million pounds in weight. And you can see here, that's the assembly of a rocket booster. You got the forward assembly, the motor assembly, which in the motor assembly, that's 5 segments. Those are the segments that the P-band polymer is in. And then the aft assembly. Each booster burns 6 tons of solid propellant every second and generates a mass thrust of 3.6 million pounds. Next slide, please. This is just a picture of when we make our polymer. We start off with chemicals that are liquid, look like water. And then it's an emulsion process. So at the end, we separate the liquid phase from the salt phase, and it ends up being looking like sorghum molasses. Our product that we test is sorghum molasses. We tease the guys in production saying that it's just brown stuff in a jar till it comes to the lab. That's when we say it's P-band. And we've told that to our production guys and also to the guys from NASA. So that it starts out looking like sorghum, but when they mix it with several other ingredients, it looks like it has a consistency of a pencil eraser. Next slide, please. These are some of the tests. If you're interested in, like as Matt said, I've done water testing, I've done black power testing, but all of that got me ready to do what I'm doing now. And these are some of the tests that we do to qualify our product. We do viscosity testing, acid number testing, which is basic acid-base titration, and then you can see some of the other testing that we do. Next slide. These are some of the instruments we use that you might be familiar with or want to become familiar with. We have a UV vis spectrophotometer. Over on the right, we have an auto titrator. On the bottom, we have a Carl Fisher moisture analyzer. Next slide. This is a FTIR spectrophotometer. We have acrylonitrile is a product in the P-band. We want to know if we use this amount, how much do we still have tied up in the product? That's very, Northrop Grumman gives us, or NASA gives us a list of specifications that we have to meet for our product to be qualified. So all this instrumentation, the FTIR spectrophotometer and the atomic absorption spectrophotometer are used to qualify those test results. And all of you, if you've taken chemistry, you've seen probably those instruments in your laboratory. When I started out in chemistry, those were all as Greek to me. But don't let that scare you. Don't let that scare you. You learn as you work. What you learn in class, you say, oh, that's what Professor so-and-so meant. You learn as you work. So it takes about 40 to 50 mixes to make one segment. And a segment is 12 feet in diameter and 30 feet tall. There are 2 paired boosters at a flight set, and they want them to be the 2 boosters must be built from the same lot of raw materials. They don't want P-band that we made in 2020 and P-band we made in 2015 because they want to make sure everything matches up so they will burn identically. The space launch system will go out of control if one booster has more thrust than the other in a flight set, causing a catastrophic loss for vehicle and crew. So one segment, it's 45 mixes, 850 pounds. That's 38,250 pounds of polymer. And for 2 of them, that's 382,500 pounds of polymer. So there are 5 raw materials in the total that make up the propellant for the boosters. P-band is only 12% of the propellant recipe. I can't tell you what the other raw materials are. I'd have to erase your memory. It's a proprietary. Next. So as we said, there's 2 boosters, 382,500 pounds. That's 54 batches at 7,100 pounds apiece. And each batch takes 47 hours. So that's 2,538 hours. And this does not include the testing of the lot, of the batch, the sublot, and the lot. And they're done in triplicate. So ASRC, as I said, provided the P-band for all 135 space shuttle flights. So this is approximately 5,818 batches or 41,310 pounds of P-band at 273,461 hours of production. ASRC is looking forward to going to our journey with our customer, Northrop Grumman, which, by the way, they're the only approved manned vehicle. They have taken up so many astronauts and come back down. So the others, I'm just going to say the others they're trying to be like Northrop Grumman association with NASA. The next slide, please. So our success will change the world. We are going to the moon. Next slide. And there's one more slide. This young lady, this could be you. I don't know if any of you are saying, I don't know if I want to go into science. Who wants to go into science? That's boring. My granddaughter says everything's boring. She's 15. Everything is boring. But this young lady was accidentally put into an honors geometry class. And guess what? She's a NASA space engineer. So look up her name is Deja Williams. She has some videos where she, one of them, she's rapping how to solve the quadratic equation. And one of them, she's metric unit conversions. So she's, if this could be you, this is a young lady, but it could be you as a young man. She's very talented. So I would look it up. This is I never would thought, I wasn't good with math in fifth grade, but in 8th grade, it just seemed to take off. I went into college to be a med technologist, but then all of a sudden I said, that's not what I want to do. Well, to be honest, there wasn't a lot of money in it. So I went into biology and chemistry. I've never really worked in the biology job per se. I've worked in chemistry, but it's all been exciting. I've been at American Synthetic for 35 years in April. And I've never regretted my decision to go into sciences. And I definitely have never regretted my decision to work in the liquid polymer department at ASRC. It's a good job. And anybody who's interested, maybe you can call and we can make some kind of arrangements to come on some type of tour. But we're a Michelin facility and we're a space facility. So everything is hush hush. But maybe we can try to get you a tour. So that's I'm not very good at speaking in front of people, but I enjoy this opportunity and hope I get to do it again. Thank you very much.
Thank you. You had me riveted, so I think you did great. Thank you very much, Ms. Morton. And I know that you're going to inspire a lot of the kids that I get to work with here in the Louisville area. So I'm looking forward to hearing back from them. And just put in a quick plug, this is going to be recorded. This is being recorded, I understand. And so other schools, other high schools that maybe couldn't be here today because of all the 100 million things that are going on, they're going to be able to come back and see this.
Okay,
so that's
thank you.
Wonderful. And I will use it as part of my lessons. And I will also look up Miss Deja Williams too.
Okay.
Thank you.
Thank you.
I'm going to now give it to Telly like I should have to start with. And let him do his piece.
Hey, Matthew, thank you, man. No problem at all, sir. Excited to be here. Love hearing our speakers and our industry partners talking. And I think the thing that stuck out for me is not only all the cool things that they're showing that they're doing in their companies, but it's local. And these are people who are from Louisville, who are from our 10-county region. So it's local, and they kept saying there's local opportunities and local things. So what I'm here to talk about is Jefferson Community and Technical College, which is in these 10 counties around Louisville, Jefferson County, Shelby County, Bullitt County, Carroll County, all around us. We have programs for you that can put you on track to potentially work in the space industry if it's something you want to do. I know we're going to be showing some pictures of some of our facilities. I'm in one of those facilities now without a mask because I'm surrounded by 50,000 square feet of amazing equipment, just like our speakers are talking about, that can prep you. And there's a picture of our building. We're located, this building is on 2nd Street near our downtown campus, and has a lot of the programs that it takes to make for perseverance to happen today. Electronics, motor control systems, pre-engineering programs, right? IT, technical training, coding, machining. If you want to, there's no parts, you don't go to a robot store to buy parts. You got to make parts, right? Just like our speakers are talking about making parts and making equipment for these facilities. Now, the great thing about Jefferson and the great thing about the programs we have is right now, if you are a Jefferson County High School senior, you can come to our programs for no cost. If you apply for a federal Pell Grant and you don't receive assistance from the feds or the state, then Evolve 502 will cover your tuition if you come to Jefferson Community and Technical College. And just like our speaker said, if you've never been exposed to this stuff, you're not sure what you want to do, if there's ever been a time to try, now is the time to try. If you like working with your hands, right? If you like taking something in the classroom and then immediately applying it in our labs, whether it's welding, whether it's taking apart something or using CAD to design a piece of material that you want to print out in this big, massive 5-axis machine behind me, you can do that at Jefferson Community and Technical College. And you can do it for tuition assistance and do it for almost little to no cost to come to JCTC. That's just a few of the programs we have. One of our speakers is referencing our great partnerships we have with the University of Louisville and some of those. So you could come to Jefferson for 2 years, take programs in our technical fields like computerized machining, maintenance, automation, robotics, all those programs, or take some courses like in chemistry and calculus and transfer to one of our local universities here in Kentucky or to our friends right over the river in Indiana and even Ohio. The great thing about programs right now is this is where the jobs are locally, and this is where the jobs are going in the future. So when you complete programs like this, it gives you kind of a clear purpose and wonderful job security to work in these industries. Now, it's great to see what I jokingly call Percy, the Perseverance rover, that it's going to take off and see that. But when I look at that, I see things that my students at Jefferson Community College are doing every day that will eventually contribute to that future landing, right? Or that future visit to Mars, and probably that future visits to the moon that are going to take place. This is going live on the Jefferson Community and Technical College Facebook live feed. So very easily, you can reach out to us via Facebook. You can reach out to us online and get more information about these programs. So my name is Telly Sellers. I'm the Associate Vice President of Technical Education at Jefferson Community and Technical College. And if you're not sure how to get involved in space, if you're not sure what your next step is going to be, well, come to JCTC. Let's show you some of these incredible programs that we have, show you how to get them paid for almost little or no cost, and get you on a career path that'll give you choice and really help everybody in the future of where we're going. Matt, that's all I have. I can answer some questions that you may have or anything you might have thought that I have missed. But I'm just so excited today. I'm going to have the NASA live feed on in my office and in my house tonight with my kids all night long because I'm dying to see what happens.
Yeah, we hope it happens well.
It will, yeah.
Thank you to everybody who came today. I think it gives a really good taste of what's possible for you guys who are out there and being our participants. Do reach out to us. We had a couple of our emails put up, and we can get back to you through Facebook Lives, my understanding. And we all have ways of, helping you get on a path. Really excited about the program coming up through the public schools that were just mentioned. And that's where my partner, DeAndrea Holcomb, and I work out of Jefferson, but in those high schools. So look for us if you want to find out as a 16 or 17-year-old, how to get going. And unlike Miss Morton, I think we could probably arrange a tour of this wonderful space without having to make you sign some secret service agreement or something. Once COVID's over, we'll try to get you lined up with some tours. The last plug here in about our last minute is that at first we intended this to be a live event, and we were intending to, of course, invite many different people from different industries around the area. That's still on the ticket. We still want to try to pull that off come perhaps as early as next fall, but definitely next year. So if you're a younger student, look for that. Ask about it. We're going to try to do this whole thing again, only a live version of it, come next year, next school year. That's our hope. I believe that I think we kind of wrapped up. I do want to let you know that for some of you who are tuned in right now, you will be going to a different feed. That's a student-only feed. I think your teachers have that direction and know how to get you there. And we do have a wonderful speaker named Bo Lowry, who I'd hoped to introduce a little bit more during this session, but we kind of ran out of time. But I do want to let you know that Bo's talking in that next session. It'll be on a different link. And Bo's had more than 40 years of involvement in space science. There he is. And ranging from space-focused amateur radio organizations to contributor to all things related to space and science. You may have seen him in your local library, perhaps in your high school. He's been around. He is a guest speaker, a designated speaker for NASA, and we're looking forward to hearing from him come next hour. And I believe that kind of ends our session. If there's nothing else from anybody else, please do reach out to us. Is there? I know that that yes. I lost it. Kelly, can you give us one more, just real quick? Tell them how they can reach back to us again, because I didn't quite understand that, and then we'll end with Telly.
Absolutely. Absolutely. Everybody, you're watching us through our Facebook live feed. We're going to put the contact information inside the chat below this message. You also can contact us through our Facebook page, and you also can just Google opendoors.us or Jefferson Community and Technical College and Google that and get connected to our programs. And through those, we can definitely arrange a tour and get you to one of our campuses. Just make sure when you do that we're safe and we mask up. Matt, you did a wonderful job. To all of our speakers and employer partners, I want to thank all of you so much. It takes all of us together to work and help people have choice and access to these wonderful programs and opportunities that we have. Matt, thank you for everything you've done, and I'll turn it back over to you, sir. Thank you.
All right. Go to the NASA links, nasa.com Perseverance links, and you can see the landing, which I believe is scheduled to be at about 3 p.m. today. If so, you can do that on your own. Thank you again, everybody. Ms. Morton,
thank you.
And Mr. Bowling, and we're looking forward to hearing from you in a little bit, Bo. Thank you, everybody.
Bye, everyone.
Goodbye. Have a nice day.